All right. So here we're going to look at, we're going to continue with 1.4, Extrema and average rates of change. So here we looked at the word problem yesterday. Today we're going to look at some graphs. So estimate and classify the extrema for the graph of each function. Support the answers numerically. Remember the extrema that we have are the, oh, that's too big. We have a maximum, okay? But then maximum, we can have either a relative maximum or an absolute maximum. All right, so the top of this area and the top of the top, or the top of the toppest top. And then we also have minimums. So we have a relative minimum and an absolute minimum. So again, absolute, relative is just in that area, that section. Absolute is the absolute lowest point, okay? So those are the ones that you're going to be asked for on placement tests. So if we look at number 18, uh, we have a minimum and we have a maximum here. So notice that it goes here, goes up, 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 and then it starts to decrease right there. That's our turning point. That's our maximum. Okay, so that is a maximum. But then is that a relative maximum or is that the absolute maximum? So does it go any higher than that? Actually, it does. This one goes up forever. So that one, because of that, that means this is a relative maximum. All right, so there you have a relative maximum at negative 1.5, comma 5.7. That's about 5.7. Doesn't reach uh, to the 6 yet. I'm just going to assume it's 5.7. All right, could be 6. I don't know. Whatever you want to put. And here, then is there a minimum here? Yeah. So here it goes decreasing, 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 and then suddenly it increases right here. That's another turning point. That's a minimum. And is that the relative minimum or the absolute minimum? So on the left side, it actually goes all the way to a negative infinity. So this is another relative minimum. So we have a relative minimum, and there you get 1.5. Sorry, I wasn't looking at the scale. It looks like it's going by 2 on the x-axis, so we get 2.5. And that one looks like it goes to 6, negative 6. All right, and this one would be negative 2.5. Sorry about that. Oh, it could be 3. Yeah, it could be 3. All right, but we want to support it numerically, so you'd have to yeah, you'd have to look at 2.5, plug in negative 2.5 into f of x, and plug in negative something smaller and something bigger than that. So negative 2 and f of negative 3. All right, see what you get. So yeah, there you go. And feel free to try the others. Actually, try this one's kind of messy. I don't know why they wrote it like that. Um, yeah, why don't you try number 16? Try 16 there. Put this on the notes. All right. And here, using the graphing calculator to estimate everything. So yeah, here you could just approximate to the nearest hundredth. So you just want to use Desmos.com, not /scientific, just Desmos. And you can graph these. So if you want to graph 26, for example, and if you want to try 24, that'd be good. Actually, try 25. Try 25 so you can check your work. All right, and I'll do 26. Just put it into the graph calculator. All right. Let's go here. There we go. That's not it. That's the one. All right. So we have f of x. You can put f of x if you want. Equals, and doing 26, so x to the fifth. So x, and then a to the b, fifth power. Notice that the cursor is still up there, so click down here. Minus 2x cubed minus 2x, and then cubed a to the b, 3. Bring it down. Minus 6x, minus 6x, minus 2. All right, there you go. Yeah, so here we have, Desmos is really nice because you could just click on it and then you get those gray points. So it tells us where we have our answers. And there, our relative minimum, our relative maximum is negative 1.36, comma 6.54, and relative minimum at 1.36, comma negative 10.53, or 54, sorry. Uh, uh, and going back, let's put that there, let's put these back. There you go. Use desmos.com. All right, so relative maximum at negative 1.36, comma 6.54. Relative minimum at 1.36, comma 10, negative 10.54. And these are the x coordinates that we're looking at. Okay, where it happens, where the relative maximum and relative minimum are. Okay, sometimes they just want to know where it happens. If they want to know where it happens, just the x coordinates. If they want to know how high or how low it gets, that's looking at the y coordinates. All right, and that's number 26. Okay, let's put that on the notes. All right, there we go. And now we're going to look at optimization. So this is real world stuff. So like we want the great, usually when we're doing business and things like that, you want the greatest amount. Okay. So you're looking for the greatest or the least. So you're looking for the maximum or the minimum. And yeah. So I'll put this on the notes because it's a cute orange. Oh, look at that orange. All right. So here we have one that has graphic design. Yeah, if you want to try this one, feel free to. I'm gonna do this one because it's geometry. So it says determine the radius and height that will maximize the volume of the cylinder shown. So sometimes when you want to choose like the to maximize the soda can or some kind of food can or whatever, yeah, you have to do this stuff. So round to the nearest hundredth of an inch. Okay, so this SA is the surface area of the whole thing. So they give us the surface area. We need something. We need something. Okay, R is the radius. H is the height. Okay, so we have the radius and the height. So they give us the surface area. Now we need to know the formula for the surface area of a cylinder. Now, how do you find the surface area of a cylinder? We have three surfaces. We have the top circle, we have the bottom circle, and then we have the outside, the part that wraps around those two circles. Okay, so those are the three things that we need to find the area for. Now, luckily, those two circles are the same. So what's the area of a circle? The area of a circle is going to be 2 pi r squared. Pi r squared. That's the area of a circle. Okay, but how many circles do we have? We got one, and we got two. So we have two circles. So that's 2 times pi r squared. And now we need to find the area of this part that wraps around everything. Okay, so we need the surface area of that. How do you do that? If you can imagine, um, actually, let's do this. So here, what you want to do is you want to find their circumference, the distance from the outside of the distance around a circle. Okay, the distance around that circle. Okay, so here we're adding. So the circumference of a circle is 2 pi r. Now, if you can imagine cutting this right down the side, and then you stretch it out, you'll actually end up with, if you roll it out, you're going to end up with like a wrapping paper. You're going to get a rectangle. Okay. And here, this part that gets straightened out, that's our 2 pi r. That's our circumference. Okay. And then this part over here, well, the part where you cut down the middle or down the side is called the height. All right. So here, the area for that is going to be 2 pi r times h, base times height, base times height. So that's one way to remember the surface area of a cylinder. Circumference of the circle times the height. Okay. Yeah, because honestly, there are so many formulas to remember. Uh, Sometimes you just want to think about it. Okay. There you go. And that height never changes. As you go down the circle, right? The height is always going to be the same. Okay, so we have that, and we know 20.5 pi inches squared is our surface area. So we have 20.5 pi inches squared equals 2 pi r. Now here we're going to have a lot of work, so be prepared. 2 pi r squared plus 2 pi r times h. All right. How can we simplify this? Well, notice that we have a pi, and we got a 2 and a 2. So let's do this. Let's divide everything by 2 pi, just so we can make some smaller numbers. Okay, so we're going to divide everything by 2 pi, because we want to get some smaller numbers. Do you have to? No, you don't need to. But 20.5 divided by 2 is going to give us 10.25. And then the pi's cancel out. Here cancels out, cancels out, cancels out, cancels out. So what are we left with? Equals r squared plus r times h. Ooh, that looks much nicer, doesn't it? Yeah, so here, this is actually one equation that has two variables. Now, are we able to solve for two variables using one equation? Usually, most of the time, no. So what we have to do is we have to get another equation. So that being the case, we need another formula for the cylinder. So what other formula do we know for cylinder? Well, we know the volume. Okay, and what is the the formula for the volume of a cylinder? The volume for uh, the cylinder is going to be pi r squared. Okay, so imagine this circle, area of this circle, and then you don't want just that one circle. You want it here, 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 all the way to the top. You want all of that, all of the inside. Okay, so I just imagine that circle going up and down, up and down. So that's how much space you have. Okay, so that's pi r squared times h, that whole distance. And that's how you find the volume of a cylinder, the area times the height. Area of the base times the height, just like for a pyramid. Okay, so here we have R and an H as well. Okay, we also have a V, but oh well. What can you do? So here I'm going to solve for H because it looks easier to solve for than R. So that means we're going to move everything to the left side. So I need to get rid of this R squared plus R squared and this times R. So always get rid of the plus and minus first. So we subtract R squared from both sides. And those are not like terms, so we just leave it as it is. 10.25 minus R squared equals, this cancels out with that, equals RH. And how do you get rid of a times R? Opposite of multiplying by R is dividing by R. So we divide both sides by R. Big, oh, that's an H, oops. And divide both sides by R. Big fraction bar, cancels out, cancels out. And we get H equals 10.25 minus R squared over R equals H. All right, so this is what we're gonna substitute because we can't solve for two variables using one equation. We need two equations, so we're gonna substitute this into that. Okay, even though they didn't give us the V, we're still gonna use that this formula. Okay, so here we end up with V equals pi R squared, and then our H, instead of H, I'm gonna plug in 10.25 minus R squared over R. That's our h. Can you simplify it? Yeah, you can. This can cancel out with this. All right, you can distribute that r. You can actually simplify this to v equals pi times, sorry, you can simplify this to 10.25 pi r minus pi r cubed. Okay, when you distribute these two. All right, but I'm going to show you, yeah, you don't need to do that. You can. Okay, makes it easier, but I'll show you the harder way, just writing it just the way it is. Yeah, that's the lazy way to do it. All right, so here, what we're going to do is we're going to graph this. Graph this one. Graph. So on Desmos. Let's go to Desmos again. Here we go, Desmos. Exit that. And I'm going to put V. Can I put V? I'm not sure. V equals pi r. Yeah, looks like we can. Squared. And then parentheses. Oops. Bring the cursor down. Parentheses. And I'm gonna hit division for now so I can get that fraction bar to lengthen itself on its own. 10.25 minus r squared over r. And there we go. So it's immediately recognizing the v as a y and the r as an x. Okay. So here our r is the x, v is the y. Now, do we need to know the v? No, we don't. Okay. So this is just telling us that the maximum volume. Oh, it talked about volume. So to maximize the volume, maximize, it means the highest point. The highest point is actually all the way in the back here, but that's impossible. That's a negative radius. You can't have that. So here the maximum is going to be this one right here. So our R, remember, is the X. So our R is going to be 1.848. That's the R that will give us the biggest volume, 39.681. Okay, 1.848 or 1.85. So there we go. I'll put this over here. Take a picture. La, 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 la. There you go. Put in the notes. All right. And then go back to the PowerPoint. Is it this one? So our R, so relative maximum is going to be R equals 1.85. There you go. But hey, don't we need the height? Yeah. So what are we going to do with this 1.85? Is there a formula? Is there an equation that has R and H in it? Just R and H. Yeah, this one over here. So we're going to plug this into that one, and that's going to give us H equals 10.25 minus 1.85 squared over 1.85. So you just replace that 1.85 into all of those R's. Okay, you can calculate that on your own if you want. I'm going to use desmos.com/scientific. And when you do, you get H equals 3.70 inches. And that's it. Yeah. These are inches because it says inch. All right, and that's it. So 1.85 inches and 3.70 inches. All right, how much time we got? Oh, we got a lot of time. Okay. We're actually going to talk about the last thing today, which is the average rate of change. Now, this one is a pretty common one to see as well in tests. Okay, an average rate of change. So basically what it is, it's going to be um, how much it's changing by. So as a graph changes, all right, you can count like from one interval to the next how it's changing. Okay, but that would be a lot of calculations. So we're just finding the average rate of change. Now the way to do that is just like in eighth grade math, when you talked about mean, median, and mode for finding the average, it's the same thing, right? So you just, it's also, you can think about the slope, okay? So here our slope is going to be, oh, and sorry, these are secant lines because from geometry, they intersect twice, okay? So we're finding the slope of this line is going to give us the average rate of change. So how much it changed on average between here to here. Okay, so this is the y. So you're going to have 2 points, x1, y1, x2, y2 basically. All right, so it's going to be y2 minus y1 over x2 minus x1. Hey, that's a slope. Okay. All right. So these aren't too bad. It might seem like a lot of work, but it's not too bad. So I think you'll like it. Let's see. I'm gonna do 40. And why don't you do, I think 41 is actually nicer than 40. Check the answer. Yeah, 41 is not a smaller number than mine. All right. So here you have they're going to give you a function and then they're going to give you an interval. Okay. So it says find the average rate of change of each function on the given interval. Okay. So the interval is your x1, the lowest, the left point, the farthest left, and then you have your farthest right. Okay, x2, not x and y, x1 and x2. Okay, so to find the y's, we have to plug those in. So we want to find f of 3 and f of, oh, sorry, these are h. H of 6. All right, so h of 3, we're just going to plug those into our formula, negative, and wherever we see a x, we're going to plug in a 3, the negative 3 to the fifth, minus 5 times x, which is 3 squared, plus 6 times 3 minus 9. All right, and then when you do that, you get negative 279. And here h of 6 is going to be the same thing, negative 6 to the 5th minus 5 times 6 squared plus 6 times 6 minus 9. If you plug that in, you should get um, negative 7,927. Sorry, 29. All right. So now we're going to plug that into our formula. So our slope is h of 6 minus h of 3 over 6 minus 3. And there you go. So we have negative 7,929 minus negative 279 all over 6 minus 3 is 3. And if you do that, we end up with negative 2,550. And that's it. So hopefully that makes sense. When you're calculating these, though, make sure that the parentheses don't go around that negative because we are substituting a positive 3 there. Okay, I don't think I mentioned that. Okay, if you substitute a negative 3, yeah, make sure to put parentheses around the negative. Okay, but since we're multiplying by a 3, just don't put parentheses, or you can put negative 3. Negative parentheses 3, the 5th. All right, so try it out, see how it goes. Put that on notes, and try number 41. It's not too bad. Then, should we do one more? Yeah, okay. I guess so. Let's do this one. Weather. So the average high temperature by month in Pensacola, Florida. Hey, sounds like Home Alone. I don't know. Pensacola, Florida can be modeled by f of x equals negative 0.9 x squared plus 13x plus 43, where x is the month and x equals 1 represents January. So January is 1, basically. Find the average rate of change for each time interval. Okay, so here they give us months. Okay, and like any test, if they give you a real life problem, then you have to try to associate a number with those things that they gave you. So here, April, if January is 1, April is going to be 4. It's the 4th month. So 4. And then May is the 5th month. So 4 to 5. July is the 6th month. I'm just kidding, the 7th month. To the November, which is the 11th month. All right. So for A, you want to find f of 4. F of 4 is going to be negative 0.9 times 4 squared plus 13 times 4 plus 43. Plug it into Desmos. Boop, 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 and you get 80.6. 80.6. Plug in 5. Negative 0.9 times 5 squared plus 13 times 5 plus 43. Plug it into Desmos. Boop, 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 boop. And you get 85.5. So the average rate is going to be f of 5 minus f of 4 over 5 minus 4. Now you're probably thinking, Mr. T, can you put f of 4 minus f of 5 over 4 minus 5. Yes, as long as those x's line up. Okay. If you don't, as long as you don't switch them. Okay. So switching them is bad. Like if you had over 5 minus 4, that would be bad. Can't do that. Okay, they should line up. All right, and then when you do that, you get 85.5 minus 80.6 over 1, which gives us 4.9 degrees. That's how much it changed, the average change between those 2 months. All right, and you can do the same thing with July. And yeah, why don't you try it for July? Okay, try it out. I'll put the answer down here. Actually, why don't you pause the video and then I'll do it in 5, 4, 3, 2, and 1. There you go. So yeah, you should have got negative 3.2. So that tells us that it changed, the average change is decreasing. Okay, the average change, it decreased a lot there. Okay, from the 7th month to the 11th. And that is that. Any questions, just let me know, and yeah, we can go over it later. Thanks.